Right, so we're just going to do a quick test to determine if your vehicle has a smart alternator or not. Because you don't want to end up in a situation where you think your vehicle is putting out, um, it's not putting out enough voltage, and thinking that there's an issue with the alternator. Let's say you're into music and this sort of stuff. No, as you can see here, right, this is just a quick test. If you don't have a scan tool, you can use this here. Is this device replaces a cigarette lighter and gives you a use report, because I don't smoke. Smoking is bad for your health, right? So as you can see, it shows 13.6 volts and 30.5. Now it's going to vary. It's going to vary the voltage. Why? Because the headlight is on in the vehicle, and I want to turn on the lights also in the vehicle. Right? So as you can see, the 13.6. Let me put the fan on. So you see we're holding steady at 13.6. Right? So now let's decrease the load on the alternator. So I'm going to take off the air condition. I'm going to take off the headlight. I'm going to take off the lights within the vehicle. Now you see, 12.9. Sometimes this goes down to 12.1 volt. Right? So alternatively, if you can invest in a smart scan tool, you can pull up the data pins for the alternator. So as you can see, the data pins that we have here is battery voltage, and we have the duty cycle of the alternator. Right, so this is with little or no load. So we just have running lights. We have just the deck on. No, nothing much. And we have no load on the system. Right, so you see the voltage goes to 12.6. It says almost the same thing here. So now I'm going to increase the load of the vehicle. Putting on the headlight. Putting on the air condition. Turning on the lights within the vehicle. And I'm going to put on the seat heaters. So as you can see, the voltage is going up and the duty cycle for the alternator is also going up. Alright, so that's one way you can test to see if you have a smart alternator or not. So because there's more electrical load on the system, because there is a battery current sensor on the battery, the ECM has enabled the alternator to push more voltage. Now by doing that, it's going to increase the load on the engine, because when an alternator spins, it actually gets tight when there's voltage applied to the relevant points. So the computer has seen that and it has increased the load. But by doing that, increase the output, but by doing that, it's going to reduce your fuel economy. So vehicles that have smart alternators, when you decrease the load on the engine, so let's say you're driving and you're coasting, what the vehicle is going to do is going to remove some of the load of the engine by decreasing the voltage that the alternator is putting out. Now if you want to get super technical, you can also use a picoscope. So what we do, we have a picoscope, so we can look at the wiring diagram, right? Because wiring diagrams are very important. You have to learn how to read schematics. Look at the wiring diagram and use, sorry, not the data pins, one of the pins. So we will use the wiring diagram to determine which one of the pins is responsible for your duty cycles of the alternator, and you can hook up your scope to those pins and you can look at how the ECM controls the voltage of the alternator. Right, you can also do this by graph, and you will see that it's constantly changing the duty cycle of the alternator, and by doing that, it's going to change the voltage that the alternator is putting out. And by lowering the voltage, you have better fuel economy.